to restore the floodplain, to bring it back to its more natural form before the dam was put in, and improve the wetland area there. Our main goals with the floodplain were to conduct surveys to see what the current stream looks like now, and floodplain, and find out how much sediment needs to be removed from the floodplain if the dam is going to be removed, because if the dam is removed, the water table, that groundwater level, is going to fall, so the creek level will most likely fall as well, and it'll cut through all those sediments that are built up behind the dam and on the floodplain. So our first goal was to look at that, and then the second goal was to try to come up with some restoration plans. I'm going to talk to you about the sediment. So to do this, I guess I'll orient you first. The dam is right here, and here's the small pond, here's the large pond, so the lake is somewhere over here. We took all these green dots right here, are measurements of elevations that we took, and along these yellow lines are areas we took soil cores across the floodplain. So when we took these soil cores, we were looking for 3 different levels to get an idea, or 4 different levels to get an idea of how much sediment was there. We were looking for the floodplain elevation, so what you're standing on, also the pre-settlement surface, so that's where the floodplain was before the dam was put in place, so before all the sediment got blocked up behind the dam and redeposited on the floodplain. Then also the meander surface, that's where since it's a meandering stream, it's going to travel along its floodplain. However, with the dam in place, they blocked the stream from traveling, and that's why it's so straight right here. They straightened it so that it wouldn't move along its floodplain anymore. However, we can still see the old surface from where it traveled upon. And then the last thing we measured was the water table. And so at all these locations with green dots, we took that, and I'm now going to show you a figure which shows this sediment wedge that we found that is pictured along this red line. Okay. So here's the sediment wedge, right here, sitting upon the pre-settlement surface. So that's the area of which we would have stood on back in 1850, right, before all the sediment was deposited on it. And then underneath it is the meander plain. And here's the dam. So our goal was to calculate how much of this there is, because the idea is to restore the floodplain, to bring it back so it could be an active wetland perhaps, and also to prevent the disconnection of the floodplain from its stream. That will likely need to be removed. So to do that, we took all of our elevation measurements and entered it into a mapping program called SURFER. And these are the different topographic maps that were created out of all of our data. For the pre-settlement surface, we were only able to get 2 areas in which we could find buried wetland materials. So that represents the buried pre-settlement surface. And so what I did was I took the average between those 2 points. They were very close in elevation. And I entered it into the program, so it calculated the volume above the area, above the elevation of the pre-settlement surface and the land surface, so this top one. And when I calculated that, I got approximately 37,000 cubic meters of sediment. So that's about 2 to 3 feet of additional sediment, since the dam has been put in place, is now on the floodplain. This is approximate. There's berms that are higher that we didn't get measurements from in this. There's also going to be areas which are lower along the floodplain, so this is probably closer to an average. What can we do with this sediment? If it's dredged, we could just push it off to the side to a nearby farm field. The owner of this floodplain area right here, his name is Fred Wolf, and he is in very strong support of restoring it. So we could just put it on his farm fields. It would be really good soil, fertile, and it'd help raise it above to prevent flooding. You could also move it to the ponds to help fill it, or sell it off-site. So with that, I'm going to pass it off to Lauren to discuss stream restoration.
I'm going to stay a little closer. Okay, so the next thing that we wanted to do, and of course I'm a designer, so I'm always wanting to draw something. So I'm like, how would you actually restore the stream? You know, how would this work? And the most logical place to begin, and I think most stream restorationists do begin with, is looking at a reference reach. And a reference reach is a natural reach of stream that is relatively unaffected, and hopefully really hasn't been affected by man. Of course, in the Black Earth Creek Valley, this is fairly difficult to find, but we did find a site pretty close to our project site. So this is our project, or the floodplain study area here, Lake Marion. And then just south of us, this is Olson Road, we found a reference reach to study, and this is an image of that. Okay, so this is a map from GIS. This is the reference reach that we found. You can kind of trace it here and see that it really actually hasn't changed that much in plant morphology since 1937. So the first thing we did this summer is go out there, and Sam and I, we're in our bikinis, we kind of scared to do those pictures, but we jumped into the stream with our measuring rods and our measuring tape, and we basically cut cross sections to understand the cross-sectional profiles of the stream, both at the meander bends and the meander arms. We were trying to understand the relationship between the base flow and bank flow height, and stream profile relationships. And then we took this plan information and I put that into an AutoCAD program, which I'm familiar with, and was able to get some more plan geometries such as the belt widths and radius of curvature, at valley slopes and channel slopes. So we took this information and then applied it to our study area. Just to orient you against this, is a little bit different. This orange line represents our study area. Black Earth Creek coming in here in a natural meander and straightening out and widening out before it gets to the dam. These yellow lines represent 2-foot contours, so that was kind of the best information that we had to work with. What was interesting too, once you got these contours, you could also trace on the contours and in foot where the old stream bed used to go. You can see the old scrapes. These are actually exposed groundwater, and there's a lot of green canary grass, and actually a really nice sedge meadow in this corner here. So the first stream restoration plan looks at using the information, the geometric information that we found at the reference reach. And so this meant creating this very low gradient, high sinuosity, lots of meandering reach in the widest area of the floodplain. However, that didn't get us down far enough. There's a great difference if we started about here on the creek. It's about 7.5 feet lower at this point below the dam. So that's what we're trying to take up, is that vertical gradient with the plan profile. And so in this plan, we needed to go to a higher gradient, lower sinuosity reach here. The other thing that we're trying to do in both of these schemes is restore a very generous wetland floodplain. What we found in our public land surveys, the historic public land surveys, that this area did used to be a wetland. It used to be a marsh. And when we were out digging in the mud and the dirt this summer, we also found buried wetland soil, so really fibrous soil. So that was actually really cool, so digging for gold. And so we want to restore the wetlands in this area, and Fred Wolf, he's the property owner. He owns all this land, and he has just been the biggest champion of this project. And he is so excited to restore the stream, to restore these wetlands here, and he just wants to get going. So he's super jazzed about this. And then there's a bunch of other people in the community too that are really jazzed about not only restoring this as a trout habitat, this is a class 1 trout stream, but also kind of inviting our friends, the frogs and the turtles, back, and that's by creating these natural scrapes. So we've got some of them existing, which we should preserve, but maybe we can create some more in the landscape that have these really shallow banks where frogs and turtles can clamber from land to water pretty easily. The second floodplain restoration is really not all that different, but it looks like creating one single moderate gradient channel that has a little bit less of a meander. One thing that both of these schemes do as well is we avoid this dam structure. So the dam is right here, but it also has this long concrete retaining wall that extends out from it. What we're trying to do is avoid that so we don't have to remove that structure. There's a $400,000 dam removal grant that the village has been awarded. And so we're trying to avoid using that money to remove the structure. We can do this by wiggling around it. And it also might serve a purpose from an engineer standpoint as a grade control structure to avoid head cutting upstream. In addition to the engineering purpose, the dam is it's been a very important part of the village and town of Mazomanie. It's part of the reason why that village is there, and so it has a lot of historic significance, and we really want to celebrate that as well. So we want to make it safe, make some safe grading changes around it, and maybe some landscape architecture improvements to really commemorate that significant structure. And then lastly, creating trail systems. This would happen in both plans, but there's actually like this little wedge connection between Mr. Wolf's property and the DNR right here that takes you to the high school, which you'll see in the next exhibit, or one of the next exhibits. And then you can cross at the dam here and then get into Lake Marion. So there's a real connectivity opportunity in this zone. This diagram really walks us through, so Sam was talking about this wedge effect. So behind the dam we have this accumulated soil that's about 6 feet deep, then tapers off to 2 feet. When you restore a stream, you really want to create a natural connection between that base flow and the bank flow. And that's about a 1.5 recurrence interval, less if you want to create wetlands. If we did not remove that soil, this is kind of what you would have. You would have to cut through that wedge, and if you didn't create that connection, during a storm event, the water would just not be able to overflow its bank. You get a lot more stress on the sides, a lot more erosion, and potential downstream flooding. So to avoid that, we do recommend creating this wide wetland restoration area, moving that soil potentially to the farm fields, or filling a small pond, and really creating a diverse habitat. There is a precedent for that. It's a pretty exciting project that a couple of our colleagues from UW were involved with, Eric Booth and Steve Lohide in the Water Engineering Department. It's the East Branch Pecatonica River Restoration. It's near Blue Mounds. This is an image of it here restored. This was covered in woody shrubs just 6 years earlier. It was a collaboration between the Nature Conservancy and the Wisconsin DNR. And what they did here is they scraped the floodplain, they removed the soils. I think they actually donated or sold part of the soils. And then they seeded it with a native sedge meadow mix. And this is what it looks like just 4 years later. So very successful precedent in the driftless area for this type of work. And then lastly, zooming out, this is the area that we've been talking about. And this area in yellow is all Mr. Wolf's property that I was telling you about. And Mr. Wolf and a few others, Scott Stokes, who's become a friend of ours, are involved with the Wolf Run Association, and they have this bigger vision of restoring the Black Earth Creek corridor, creating opportunities for not only recreation and nature observation, but trails, and really making this a destination for the village of Mazomanie, the town of Mazomanie. So with that, I think we're ready to sum up. So